Hello, in this lecture we will find out the area of quadrilateral ABCD using two different methods. In the drawing we have quadrilateral ABCD. We know that side AB equals to 4 units, side CD equals to 2 units, and we also know that AD equals to CB, angle DAB, this angle equals to 30 degrees, angle ABC equals to 90 degrees, and we want to find out the area of this quadrilateral ABCD. So we will start with the first method. In the first method, we will draw perpendicular from point D to AB. And we will define the touching point of the perpendicular from point D to AB as point E. So this angle equals to 90 degrees. And this angle also equals to 90 degrees. We will define line segment DE as A, that is to say the length of line segment DE is equal to A units. Then we will focus on the right triangle ADE. On the right triangle ADE. We know that sinus 30 degrees equals to DE over AD. Sinus 30 degrees is 1 over 2, and DE equals to A units according to our definition, so we will substitute DE by A over AD. So we will cross multiply equation number 1, and we will get that according to equation number 1, AD equals to 2A. We found out that AD equals to 2A. So we can write here that AD equals to 2A. According to what is given us in the question, AD equals to CB from one side, but from the other side we already found out that AD equals to 2A. So from this equation we will get that CB also equals to 2A. CB equals to 2A. So we can write here that CB equals to 2A. In the next step, we will draw perpendicular from point D to CB. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees, and we will define the touching point of the perpendicular from point D and CB as point F. I will present to you a new rule, rule number 1. According to rule number 1, the sum of the angles in any perpendicular, in any quadrilateral, is equal to 360 degrees. I'll repeat again on rule number 1. According to rule number 1, the sum of the angles in any perpendicular is equal to 360 degrees. So if we focus on quadrilateral DFEB, on quadrilateral DFEB, the sum of the angles inside quadrilateral DFEB must be equal to 360 degrees according to rule number 1. Quadrilateral DFEB has 3 right angles, 1, 2, 3. The sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle that we will define as angle X. So the sum of those 4 angles must be equal to 360 degrees according to rule number 1. Here we will substitute 270 degrees from this equation, and we will get that x equals to 360 degrees minus 270 degrees, it equals to 90 degrees. So we found out that angle x is a right angle, that is to say it equals to 90 degrees, so we substitute angle x by a right angle. So quadrilateral DFEB has 4 right angles, and we also have rule number 2. According to rule number 2, any quadrilateral that has four right angles must be at least a rectangle if not a square. So if not a square, it must be a rectangle. I will read rule number 2 again. According to rule number 2, any quadrilateral that has four right angles must be at least a rectangle if not a square. So, according to rule number 2, quadrilateral DFEB, this quadrilateral is a rectangle because of the fact that it has four right angles. So I write it down. Quadrilateral DFEB is a rectangle. According to rule number 2, and we also have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. So I repeat on rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other, so it means that the opposite sides of rectangle DFEB are equal to each other. That is to say, DE equals to FB, DE equals to FB, according to rule number 3. But according to our definition, DE equals to A. So we can write here that DE equals to A. And from this equation, we will derive that FB also equals to A. Okay, FB equals to A. So we can write here that FB equals to A. What is the length of CF? From the drawing, you can easily see that the length of line segment CF it equals actually to CB minus FB. I'll repeat again. The length of line segment CF equals to CB minus BF. And CB equals to 2A. FB equals to A. So CF equals to 2A minus A. That is to say it equals to A. So we found out that CF equals to A. In the next step, we will connect together points D and B by a straight line. And we will prove that triangle DFB can congruent to triangle CFD. Okay. We will prove the triangle DFB congruent to triangle DFC. So why those two triangles congruent to each other? First of all, we know that BF equals to FC equals to A. We also know that those two angles are equal to each other, they are both equal to 90 degrees. So angle DFB, this angle, equals to this angle, angle DFC. And both angles are right angles, that is to say they are equal to 90 degrees. So angle DFB equals to angle DFC equals to 90 degrees. And we also have here a common side, DF is a common side, it belongs to both triangles, so we can write down that DF equals to itself, DF equals to DF. It's a common side that belongs to both triangles. I'll repeat again. DF equals to DF is a common side that belongs to both triangles. So we actually proved that triangle DFB congruent, this is the sign of congruent, to triangle DFC according to side angle side rule. Okay. I'll repeat again. We actually proved the triangle DFB congruent to triangle DFC according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you prove the two sides and the angle between those two sides in one triangle congruent to two sides and the angle between those two sides in another triangle, Then you prove that those two triangles can point to each other according to side A and side rule. And you actually proved that those two sides and the angle between those two sides in triangle DFB can point to those two sides and the angle between those two sides in triangle DFC. Therefore, we prove that those two triangles can point to each other according to side angle side rule. And from the fact that those two triangles can point to each other, we will conclude that DC equals to DB. DC equals to DB. DC equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can point to each other, therefore the corresponding sides, that is to say CD and DB, will be equal to each other. But it is given us in the question that CD equals to 2 units. And from this equation we will derive that DB also equals to 2 units. DB equals to 2 units. You can write here that DB equals to 2 units. In the next step, I will present to you a new law that is actually the law of cosines, and we will implement the law of cosines in this triangle, triangle ADB. So, what is the law of cosines? The law of cosines is true in any triangle. So we can write down that in any triangle, so if we have triangle ABC, that could be any triangle. And we know that side AB equals to A units. Side BC of triangle ABC equals to B units in its length. And side AC equals to C units in its length. And the angle between side AB and side BC is angle theta. Then, according to the law of cosines, A squared plus B squared minus 2 times A times B times cosine theta equals to C squared. Again, A squared plus B squared minus 2 times AB times cosine theta equals to C squared. Here we will subtract C squared and also add 2 times AB cosine theta to this equation, and we'll get that A squared plus B squared minus C squared equals to 2 times AB times cosine theta Here we will divide this equation by 2 times AB, and we will get that cosine theta equals to a squared plus b squared minus c squared over 2 times ab Okay, so we got that cosine theta equals to a squared plus b squared minus c squared over 2 times ab. We can use this equation, this formula in any triangle. So we will implement the law of cosines in our triangle, triangle ADB. So I'll copy this triangle in a new page and we'll implement the law of cosines in this triangle, triangle ADB. So this is triangle ADB that I copied from the original drawing. We know that side AD equals to 2 units, side AB equals to 4 units, side AB equals to 2 units. We also know that angle DAB equals to 30 degrees. So according to the law of cosines, here cosine 30 degrees equals to 2a squared plus 4 squared minus 2 squared over 2 times 2a times 4. We know that cosine 30 degrees equals to square root of 3 over 2, so I write it down. We will get that square root of 3 over 2 equals to 2a squared is 4a squared minus 4 squared is 16, minus 2 squared is minus 4, 16 minus 4 is 12. Over 2 times 4 is 8, 8 times 2a is 16a. Here we will multiply this equation by 16a and we'll get that square root of 3 over 2 times 16a equals to 4a squared plus 12 Here 16 over 2 is 8. So we get that 8 times square root of 3 times a equals to 4a squared plus 12. Here we will divide this equation by 4 and we will get that 8 over 4 is 2 times square root of 3a equals to 4 over 4 is 1. Actually here we got 16 over 2 is 8. So it is actually 8 over square root of 3 times a equals to 4a squared plus 12. Here we will divide this equation by 4 and we will get that 8 over 4 is 2, so it is 2 times square root of 3a equals to 4 over 4 is 1, so we will have a squared plus 12 over 4 is 3. Here we will subtract 2 times square root of 3a from this equation and we will get that a squared plus 3 minus 2 times square root of 3 times a equals to 0. Here we will substitute 3 by square root of 3 square, because square root of 3 square equals to 3, and we will get that a square by square root of 3 square minus 2 times a times square root of 3 equals to 0. So actually this equation is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. So we can substitute our expression by a minus b squared, that will be equal to 0. In our specific expression, a equals to a and b equals to square root of 3. I'll repeat again. In our specific expression, a squared plus square root of 3 squared minus 2 times a times square root of 3 equals to 0, a equals to a and b equals to square root of 3. So a minus b squared, it is actually a minus square root of 3 square, that will be equal to 0. Here we'll take a root out of this equation and we'll get that a minus square root of 3 equals to 0 because of the fact that the square root of 0 is 0. We'll add square root of 3 to this equation and we'll get that a equals to square root of 3 units. So we can write here that a equals to square root of 3 units. Also here a equals to square root of 3 units. And here also a equals to square root of 3 units. In the next step we will focus on this right triangle DEB, and we will implement the Pythagoras theorem on the right triangle DEB. Here PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse in the right triangle DEB is DB, so the square of the hypotenuse is DB square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to DE square plus EB square. I'll repeat again. In the right triangle DEB, according to the Pythagoras theorem, DB square equals to DE square plus EB square. DB equals to 2 units, therefore DB square is 2 square. 2 square is 4. Equals to DE square. DE equals to square root of 3 units, so DE square is square root of 3 square. Square root of 3 square is 3, plus EB square. EB is the missing variable, so we will leave it as it is, so it will be EB square so I found out that according to equation number 1, 4 equals to 3 plus EB square. Here we will subtract 3 from this equation number 1, and we will get that 4 minus 3 is 1 equals to EB square. Here we will take a root out of this equation number 1, and we will get that EB equals to the square root of 1. The square root of 1 is 1. So we found out that EB equals to 1 unit. EB equals to 1 unit. You can write here that EB equals to 1 unit. But because of the fact that according to rule number 3, the opposite sides of a rectangle are equal to each other, that is to say DB equals to DF. In rectangle DFEB. But DB equals to 1 unit, so DF will be also equal to 1 unit. And what is the value of line segment AE? The value, you can see easily from the drawing that the value of line segment AE equals to AB minus EB. AB minus EB is the value of line segment AE, So AE equals to AB, AB is 4 units, minus EB, EB is 1 unit. So AE equals to 4 minus 1, 4 minus 1 is 3. So we found out that AE equals to 3 units, so we can write here that AE equals to 3 units. Now we can easily find out the area of quadrilateral ABCD. The area of quadrilateral ABCD here, the squared brackets is the sign for the area. It means the area of quadrilateral ABCD will be equal to the area of the right triangle ADE plus the area of rectangle DFEB, this rectangle, plus the area of the right triangle DCF, this triangle. I repeat again, the area of quadrilateral ABCD equals to the area of the right triangle ADE, this is actually triangle ADE, plus the area of rectangle DFEB, plus the area of the right triangle DCF. So the area of the right triangle ADE, the area of the right triangle ADE will be equal to the base of the triangle that is actually AE times the height to the base that is actually DE over 2. I will repeat again. The area of the right triangle ADE equals to the base of the triangle that is AE times the height to the base that is DE over 2. And the area of rectangle DFEB will be equal to the width of the rectangle that is actually ED times the length of the rectangle that is actually ED I will repeat again, the area of rectangle DFEB equals to the width of the rectangle that is actually EB times the length of the rectangle that is actually ED. The width times the length of rectangle is the area of the rectangle, and the area of the right triangle DCF, this right triangle, is equal to the base of the triangle DCF that is actually DF times the height to the base that is actually CF over 2. I will repeat again. The area of the right triangle DCF equals to the base of the triangle that is actually DF times the height to the base that is actually CF over 2. So here the area of triangle ADE is AE equals to 3 units times DE, DE equals to square root of 3 units over 2. So we actually found out that the area of triangle ADE equals to 3 times square root of, it is actually square root of 3. Here, the height DE is square root of 3, so it is actually 3 times square root of 3 over 2. And the area of rectangle DFEB, this rectangle, is EB. EB is 1 times ED. ED is square root of 3. So we found out that the area of rectangle DFEB equals to square root of 3. Then the area of triangle DCF, this right triangle, it equals to the base of the triangle, that is DF. DF equals to 1 times the height of the base, that is actually square root of 3 over 2. So the area of the right triangle, triangle DCF, equals to square root of 3 over 2 square units. Here we will multiply this expression, the square root of 3 by 2, and then we will divide it by 2 in order to have a common factor with the other two expressions. Okay? In the denominator we must have 2, so we will multiply it by 2 and then we will divide it by 2 in order to have 2 in the denominator. In the next step, we will take out a common factor of square root of 3 over 2 from out of these three expressions. So square root of 3 over 2 is the common factor of those three expressions. So we took a common factor of square root of 3 over 2 from this expression. So what is left from it, after we took a common factor of square root of 3 over 2, what is left from it is actually 3. And what is left from this expression after we took from it a common factor of square root of 3 over 2, what is left is actually 2. And what is left from this expression after we took from it square root of 3 over 2 as a common factor, what is left it is actually 1. So square root of 3 over 2 times 3 plus 2 is 5, 5 plus 1 is 6, so we have 6. 6 over 2 is 3, so it is 3 times square root of 3. So we actually found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. I'll repeat again, the area of quadrilateral ABCD according to the first method equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. We finished with the first method. In the next step I will present to you how to find out the area of this quadrilateral ABCD according to the second method. In the second method, we will do another construction. From point A, we will draw perpendicular to AB. So this angle will be a right angle. That is to say, it will be equal to 90 degrees. from point C, we will draw perpendicular to CB. So this angle will be a right angle, that is to say it will be equal to 90 degrees, because we draw perpendicular to CB from point C. And we will define the intersection point between the perpendicular from A and the perpendicular from C as point E. Point E is the intersection point between the perpendicular from point A and point C. So here we actually created quadrilateral ABCE. In this quadrilateral ABCE, as you can see from the drawing, we have three right angles, 1, 2, 3. The sum of three right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, this angle that we will define as angle X. So the sum of those four angles must be equal to 360 degrees according to rule number 1, that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, in quadrilateral ABCE, the sum of the three angles is 270 degrees, plus the size of the fourth angle must be equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we will get that angle X will be equal to 360 degrees minus 270 degrees. That is to say, angle X equals to 90 degrees. It is a right angle. So we will substitute angle X by a right angle. As you can see, in quadrilateral ABCE we have four right angles, and according to rule number 2, any quadrilateral that has four right angles must be at least a rectangle. So we relate to quadrilateral ABCE as a rectangle. Quadrilateral ABCE is a rectangle according to rule number 2. And we also have rule number 3 that states that the opposite sides of a rectangle are equal to each other. So in rectangle ABCE, AB must be equal to EC according to rule number 3. AB equals to EC according to rule number 3. But it is given us in the equation that AB equals to 4 units. So from this equation, we will derive that EC also equals to 4 units. So we can write here that EC equals to 4 units. Likewise, according to rule number 3, AE equals to CB. AE equals to CB. According to the rule that the opposite sides of a rectangle are equal to each other. And if we define CB as x, then from this equation we will derive that AE also equals to x, AE equals to x, and it is given us in the question that CB equals to AD, but according to our definition CB equals to x. So from this equation we will derive that AD also equals to x, AD equals to x, and what is the value of angle EAD? The value of angle EAD, this angle will be equal to 90 degrees minus 30 degrees. Because if you subtract this angle that is 30 degrees from the right angle that is 90 degrees, we will get this angle, that is to say, this angle will be equal to 60 degrees. In the next step, we will connect together points E and D by a straight line. And we will connect together points D and B by a straight line. We will focus on triangle AED. Actually, I will copy triangle AED in a new page and we'll analyze triangle AED. Okay. So I copied triangle AD to this page from the original drawing. So we found out that AE equals to ED, that equals to x, and we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides we have those two angles that are also equal to each other. So if this angle is y, then this angle will be also equal to y. And the sum of the angles in any triangle is equal to 180 degrees. That is to say, the sum of the angles of triangle AED must be equal to 180 degrees. It means that y plus y plus 60 degrees must be equal to 180 degrees. Y plus y is 2y plus 60 degrees must be equal to 180 degrees. We will subtract 60 degrees from this equation and we will get that 2y equals to 180 degrees minus 60 degrees is 120 degrees. We will divide this equation by 2 and we will get that angle y equals to 120 degrees over 2 is 60 degrees. So we found out that angle y equals to 60 degrees. So this angle equals to 60 degrees. And this angle also equals to 60 degrees. So actually we found out that triangle AED is an equilateral triangle. I write it here. Triangle AED is an equilateral triangle. It means that all of its sides are equal to each other, so if AD is x and AE is x, then ED also will be equal to x, and all of its angles, they are equal to 60 degrees. So actually here, we know that ED equals to x, this angle equals to 60 degrees, and this angle also equals to 60 degrees. What is the size of angle CED? Angle CD, this angle will be equal to 90 degrees minus this angle that is 60 degrees. 90 degrees, this is the size of this angle, minus 60 degrees, this is the size of this angle, must be equal to angle DEC, that is to say angle DEC equals to 30 degrees. In the next step we will prove that those two triangles can go into each other. So actually we will prove the triangle ADB can go into triangle EDC, this triangle. So why those two triangles can go into each other? First of all, we know that AB equals to EC equals to 4 units. I'll repeat again. We know that AB equals to EC equals to 4 units. We also know that those two angles, they are equal to each other, they are both equal to 30 degrees. So angle BAD equals to angle CED, this angle, and they are both equal to 30 degrees. Angle BAD equals to angle CED equals to 30 degrees. And AD equals to ED equals to X. AD equals to ED equals to X. AD equals to ED equals to X. So we actually proved that this triangle ADB can go into this triangle EDC according to side angle side rule. I'll repeat again. To prove the triangle ADB can go into triangle EDC according to side angle side rule. Why? Because actually we proved that those two sides and the angle between them in triangle ADB congruent to those two sides and the angle between them in triangle ADC. Therefore, we prove that those two triangles congruent to each other according to side angle side rule. And we will conclude from the fact that those two triangles congruent to each other that CD equals to DB. CD equals to DB. Again, CD equals to DB according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles congruent to each other. Therefore, the corresponding sides, that is to say CD and DB, will be equal to each other. But it is given us in the question that CD equals to 2 units. Okay? Repeat again, it is given us in the question that CD equals to 2 units, and from this equation we will derive that dB also equals to 2 units. dB equals to 2 units. Right here, dB equals to 2 units. In the next step, we will implement the law of cosines on this triangle, triangle ADB. So I will copy this triangle in a new page and we will implement the law of cosines in this triangle, triangle ADB. Okay, so we have triangle ADB. So this is triangle ADB that I copied from the original drawing. We will implement the law of cosines on this triangle, triangle ADB, according to the law of cosines. Cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4 so cosine 30 degrees is square root of 3 over 2 that equals to x squared plus 4 squared is 16 minus 2 squared is 4, 16 minus 4 is 12. Well, 2 times 4 is 8, 8 times x is 8x. We will multiply this equation by 8x and we will get that square root of 3 over 2 times 8x equals to x squared plus 12. Here 8 over 2 is 4, so we get that 4 times square root of 3x equals to x squared plus 12. We will subtract 4 times square root of 3x from this equation and we will get that x squared plus 12 minus 4 times square root of 3x equals to 0. Here we will substitute 12 by 2 times square root of 3 square, because 2 times square root of 3 square equals to 12, and we will get that x square plus 2 times square root of 3 square, that is 12, minus we will substitute 4 by 2 times 2, so it is actually 2 times x times 2 times square root of 3 that equals to 0. Actually, this expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific expression, a equals to x and b equals to 2 times square root of 3. So we actually can substitute our expression by a minus b squared that equals to 0. Here, a equals to x and b equals to 2 times square root of 3. So a minus x, it is actually x minus 2 times square root of 3 square that equals to 0. Here we will take a root out of this equation and we will get that x minus 2 times square root of 3 equals to 0. Here we will add 2 times square root of 3 to this equation and we will get that x equals to 2 times square root of 3 units. So we can write here that x equals to 2 times square root of 3 units. Here also x equals to 2 times square root of 3 units, and here also x equals to 2 times square root of 3 units, and here x equals to 2 times square root of 3 units. Now, in order to calculate the area of triangle ADB, we will find out the height of triangle ADB. So from point D, we will draw perpendicular to AB. And so this angle equals to 90 degrees, and this angle also equals to 90 degrees. We will define the touching point between the perpendicular from point D to AB is S, point S. We will define line segment SD as H, and we will focus on triangle ADS. On triangle ADS, we know that sinus 30 degrees equals to H over 2 times square root of 3. Okay, in triangle ADS, we know that sinus 30 degrees equals to H over 2 times square root of 3. Sinus 30 degrees is 1 over 2, so I write it down. According to equation number 1, 1 over 2 equals to H over 2 times square root of 3. We will multiply this equation by 2 times square root of 3. And we will get that H equals to 2 times square root of 3 over 2. 2 over 2 is 1, so we found out that H equals to square root of 3 units. We can write here that H equals to square root of 3 units. Now it is very easy to calculate the area of triangle ADB. The area of triangle ADB will be equal to the base of the triangle that is actually AB times the height that is H over 2. The area of triangle ADB equals to the base that is AB times the height that is H over 2. So the area of triangle ABD equals to AB is 4 units, H is square root of 3 units over 2. 4 over 2 is 2 times square root of 3. So we found out that the area of triangle ADB equals to 2 times square root of 3 units, 2 times square root of 3 square units, and the only thing that is left to find is to find out the area of triangle DCB, because of the fact that the area of triangle DCB plus the area of triangle ADB will give us the area of quadrilateral ABCD, because of the fact that quadrilateral ABCD composed of two triangles, and the sum of the areas of those two triangles will be equal to the area of triangle ADB. So we found out the area of triangle BCD. The area of triangle BCD first of all, we will find out the semi-perimeter of triangle BCD. The semi-perimeter of any triangle is the perimeter over 2, and the perimeter of triangle BCD is 2 plus 2 plus 2 times square root of 3. 2 plus 2 plus 2 times square root of 3 is the perimeter. And if we divide the perimeter by 2, we will get the semi-perimeter of triangle BCD. So the semi-perimeter of triangle BCD is 2 plus 2 plus 2 times square root of 3 over 2. 2 plus 2 is 4, plus 2 times square root of 3 over 2. 4 over 2 is 2. 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter, S the abbreviation for the semi-perimeter, the semi-perimeter of triangle BCD is 2 plus square root of 3 units, and the area of triangle BCD is equal to the square root of S times S minus A times S minus B times S minus C. So we know that S, the semi-perimeter, equals to 2 plus square root of 3 units, and A equals to 2, B equals to 2, and C equals to 2 times square root of 3. It is actually the side lengths of triangle BCD. You can see here, A equals to 2, B equals to 2, and C equals to 2 times square root of 3 units. So we will put the data inside this equation, and we will find the area of triangle BCD. So the area of triangle BCD will be equal to the square root of S is 2 plus square root of 3 units times S minus A. S is 2 plus square root of 3, A is 2, so 2 plus square root of 3 minus 2 is square root of 3. S minus B is the same result because A equals to B, so it is also square root of 3. And S minus C is 2 plus square root of 3 minus 2 times square root of 3. It is actually 2 times minus square root of 3. So here we will get that the area of triangle BCD equals to the square root of 3 times square root of 3 is 3, and plus 2 plus square root of 3 times 2 minus square root of 3. We will calculate the value of this expression according to the algebraic identity that states that A plus B times A minus B equals to A squared minus B squared. Here A equals to 2, so A squared is 4. A squared is 2 squared, that is 4. Minus B squared. B is square root of 3, so B squared is square root of 3 squared. Square root of 3 squared is 3. So it is 3 times 4 minus 3 is 1, and 1 times 3 is 3, so it is actually square root of 3 square units. So we found out that the area of triangle BCD equals to square root of 3 square units. And we have already found out that the area of triangle ADB equals to 2 times square root of 3 units. And we know that the area of quadrilateral ABCD equals to the area of triangle ABD plus the area of triangle BCD. And the area of triangle ADB is 2 times square root of 3 square units, and the area of triangle BCD is 1 times square root of 3 units. 2 times square root of 3 units plus 1 times square root of 3 units, it is actually 3 times square root of 3 units. So in terms of numbers, it's 5 plus 1, 9, 6 square units. Okay? So we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. We finished with the second method. Now I will summarize the lecture. Actually, we wanted to find out the area of this quadrilateral ABCD. We found the area of this quadrilateral in 2 different methods. In the first method, we made a construction from point D. We drew perpendicular to AB. So this angle is 90 degrees, this angle is 90 degrees. We define the touching point between the perpendicular from D to AB as point E. And then we defined line segment DE as A. We focus then on the right triangle, triangle ADE. On the right triangle, triangle ADE, we know that sinus 30 degrees equals to DE over AD. In the right triangle, triangle ADE, sinus 40 degrees equals to DE over AD. And we know that sinus 30 degrees is 1 over 2. DE is equals to A according to our definition, so it is A over AD. We cross multiply the equation number 1, and we found out that AD equals to 2A, so we can write here that AD equals to 2A. But it is given us in the question that AD equals to CB. But we already found out that AD equals to 2A. So from this equation we will derive that CB also equals to 2A. So we can write here that CB equals to 2A. Then so we know that, okay, so then I presented to you rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. We drew perpendicular from point D to CB, and we focus on quadrilateral DFEB. On quadrilateral DFEB we have 3 right angles, 1, 2, 3. The sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is angle X, must be equal to 360 degrees according to rule number 1. Again, the sum of 3 angles, that is 270 degrees, plus the size of the fourth angle must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equation, and we got that X equals to 360 degrees minus 270 degrees, that is to say X equals to 90 degrees. So we found out that this angle, angle X, is a right angle. Therefore we have all angles in triangle In quadrilateral DFEB we are right angles. It has 4 right angles, and we have rule number 2 that any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. And because of the fact that quadrilateral DFEB has 4 right angles, it must be, we will relate to it as a rectangle. So we relate to quadrilateral DFEB as a rectangle, according to rule number 2. Then we have rule number 3 that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle DFEB are equal to each other. That is to say, DE equals to EB. DE equals to FB according to rule number 3. But DE equals to A according to our definition. From this equation we will derive that FB also equals to A. FB also equals to A. And what is the value of CF? It is very easy to see from the drawing that CF equals to CB minus FB. CF equals to CB minus FB. That is to say, CB is 2A, AFB is A, so CF equals to 2A minus A. That is to say, CF equals to A. So we found out that CF equals to A. Then we join together points D and B by a straight line, and we proved that those two triangles can go into each other. We proved that triangle DFB can go into triangle DFC. Why they can go into each other? First of all, we know that BF equals to FC equals to A. BF equals to F. BF equals to FC equals to A. Those two angles are also equal to each other. They are both equal to 90 degrees. Angle BFD equals to angle DFC equals to 90 degrees. And we also have a common side. DF is a common side that belongs to both triangles. So we can write down that DF equals to DF is a common side that belongs to both triangles. And so actually we proved that triangle DFB can go into triangle DFC according to side angle side rule. Okay, those two triangles can go into each other according to side angle side rule. We have those two sides and the angle between them in triangle DFC can go into those two sides and the angle between them in triangle DFB. Therefore, those two triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we will conclude that DC equals to DB, DC equals to DB. According to the rule, the corresponding sides that can go in triangles are equal to each other. Those two triangles can go into each other. Therefore, the corresponding sides, that is to say, CD and DB, will be equal to each other. But it is given us in the question that DC equals to 2 units. From this equation we will derive that DB also equals to 2 units. DB equals to 2 units. Okay. Then we implement, I presented to you the law of cosines. And we implemented the law of cosines in this triangle, triangle DFB, DAB. What is the law of cosines? The law of cosines is true in any triangle. In any triangle, if AB equals to A units, AC equals to C units, and BC equals to B units, then A squared plus B squared minus 2 times AB times cosine theta equals to C squared. Here we subtracted C squared and added 2AB cosine theta from this equation, and we got that A squared plus B squared minus C squared equals to 2AB cosine theta. Then we divided this equation by 2 times AB, and we got that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. And this equation is true in any triangle. We implemented the law of cosines in our triangle, triangle DAB. So I copied again triangle DAB in a new page, and we implemented the law of cosines in this triangle. So this is triangle DAB. We know that AD equals to 2A, DB equals to 2 units, and AB equals to 4 units. Angle DAB equals to 30 degrees. So according to the law of cosines, cosine 30 degrees equals to 2A squared plus 4 squared minus 2 squared over 2 times 2A times 4. We know that cosine 30 degrees equals to square root of 3 over 2. we have 2a squared is 4a squared, 4 squared is 16, minus 2 squared is 4, 16 minus 4 is 12. So in conclusion, we got that square root of 3 over 2 equals to 4a squared plus 12 over 16a. We multiply this equation by 16a and we got the square root of 3 over 2 times 16a equals to 4a squared plus 12. Here 16 over 2 is 8. So here in this side of the equation we have 8 times square root of 3a equals to 4a squared plus 12. And here we divided this equation by 4 and we got that 8 over 4 is 2, 4 over 4 is 1, so here we will have a squared, and 12 over 4 is 3. So in conclusion, we got that 2 times square root of 3a equals to a squared plus 3. Here we subtracted 2 times square root of 3a from this equation, and we got that a squared plus 3 minus 2 times square root of 3a equals to 0. We substituted 3 by square root of 3 squared because square root of 3 squared equals to 3. And we got that a squared by plus square root of 3 squared minus 2 times a times square root of 3 equals to 0. This expression is very similar to the algebraic identity that a squared plus b squared minus 2 times ab equals to a minus b squared that equals to 0. So we can substitute our expression by a minus b squared that equals to 0 according to this algebraic identity. And in our specific expression, a equals to a and b equals to square root of 3. So actually a equals to a and b equals to square root of 3. So a minus b squared will be equal to a minus square root of 3 squared that equals to 0. We took out of this equation and we got that a minus square root of 3 equals to 0 because of the fact that the square root of 0 is 0. We added square root of 3 to this equation and we got that a equals to square root of 3 units. So we found out that a equals to the square root of 3 units, so we can write here that a equals to square root of 3 units. Also a equals to square root of 3 units, and also here that a equals to the square root of 3 units. Then we implemented the Pythagoras theorem on this triangle, triangle DEB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, db squared equals to de squared plus eb squared. db is 2, so db squared is 2 squared. 2 squared is 4. de is square root of 3, so de squared is square root of 3 squared. Square root of 3 squared is 3. And eb is the missing variable, so we leave it as it is. So we got that 4 equals to 3 plus eb squared. We've subtracted 3 from this equation, equation number 1. And we got that 4 minus 3 is 1, so 1 equals to eb squared. We took out of this equation, equation number 1, and we got that eb equals to the square root of 1. So the square root of 1 is 1, so we found out that eb equals to 1. But because of the fact that the opposite sides of a rectangle are equal to each other, df will be also equal to 1. And what is the value of AE? AE equals to AB minus EB. Again, AE equals to AB minus EB. AB is 4, EB is 1, so AE equals to 4 minus 1. That is to say, AE equals to 3 units. Then the area of quadrilateral ABCD equals to the area of the right triangle, triangle ADE, plus the area of rectangle DFEB, plus the area of the right triangle, triangle DCF. And the area of the right triangle, triangle ADE is the base of the triangle, that is AE, times the height, that is DE over 2. The area of rectangle DFEB equals to the width times the length. The width is EB and the length is DE. So it is EB times DE. and the area of the right triangle, triangle DCF, equals to the base of the triangle, that is DF times the height, that is CF over 2. Again, DF times CF over 2. Here, what is the area of triangle ADE? The area of triangle ADE is AE is 3, DE is square root of 3, so it is the area of triangle ADE equals to 3 times square root of 3 over 2. The area of rectangle DFEB, it is actually EB is 1, and ED is square root of 3, so it is actually square root of 3 square units, and the area of the right triangle, triangle DCF, equals to DF times CF over 2. DF is 1, CF is square root of 3, all divided by 2. Here we multiply this expression by 2 and then we divide it by 2 in order to have a common factor with the other two expressions. Then we took a common factor of square root of 3 over 2 out of these three expressions, and we got that inside the brackets we will have from this expression what is left is 3, from this expression is left 2, and from this expression is left 1. So it is actually square root of 3 over 2 times 3 plus 2 is 5, 5 plus 1 is 6, so it is square root of 3 over 2 times 6. 6 over 2 is 3. So we found out that the area of quadrilateral ABCD equals to either square root of 3 times 3 square units, so in terms of numbers it equals to 5.196 square units. So we finished with the first method. Then I presented to you how to find out the area of quadrilateral ABCD according to the second method. In the second method we did another construction. In the second method, we draw here from point A, we draw perpendicular to AB, so this angle is 90 degrees, and from point C, we draw perpendicular to CB, so this angle is 90 degrees. And we defined the intersection point between the perpendicular from A and the perpendicular from C as point E, and then actually we created quadrilateral ABCE. Quadrilateral ABCE is 3 right angles, 1, 2, 3. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle that we defined as angle X must be equal to 360 degrees according to rule number 1. 270 degrees plus the size of the fourth angle that is angle X must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equation and we found that angle X is equals to 90 degrees, that is to say angle X is a right angle, so quadrilateral ABCE has 4 right angles, and according to rule number 2, it must be a rectangle. Okay, so we relate to quadrilateral ABCE as a rectangle, and we have rule number 3 that the opposite sides of a rectangle are equal to each other, that is to say AB equals to CE. AB equals to C according to rule number 3, but it is given as the equation that AB equals to 4 units. From this equation we will derive that CE also equals to 4 units, C equals to 4 units. Likewise, AE equals to CB according to rule number 3. And if we define CB as X, then from this equation we will derive that AE also equals to X. And it is given as the equation that CB equals to AD. CB equals to AD, but CB equals to X, according to our definition. From this equation we will derive that AD also equals to X, so we can write here that AD equals to X. Okay, AD equals to X. Then I copied triangle AED in a new page and we analyzed triangle AED. triangle AD has one angle, this angle equals to 60 degrees. We also know that AD equals to AE equals to X. And we have the rule that in front of equal sides in the triangle there are equal angles. That is to say, in front of those two equal sides there are those two equal angles. So if this angle is y, this angle is also y. And we know that the sum of the angles in any triangle equals to 180 degrees. That is to say, y plus 60 degrees must be equal to 180 degrees. So y plus y is 2y, so 2y plus 60 degrees equals to 180 degrees. We subtract the 60 degrees from this equation, and we got that 2y equals to 180 degrees minus 60 degrees is 120 degrees. We divided this equation by 2, and we got that angle y equals to 120 degrees over 2 is 60 degrees. So we found out that those two angles are equal to 60 degrees. Therefore, triangle AED is an equilateral triangle. That is to say, all of its sides are equal to each other. So this side also will be equal to x. So here we can write down that this ED equals to x, this angle is 60 degrees, and this angle is 60 degrees. Then we know that angle AEC equals to 90 degrees, and this angle equals to 60 degrees. So 90 degrees minus 60 degrees is the size of this angle DEC. That is to say, angle DEC equals to 30 degrees. Okay, then we proved that those two triangles can go into each other. We proved the triangle ADB can go into triangle EDC. Why? Because we know that AB equals to EC equals to 4 units. We also know that those two angles are equal to each other. They are both equal to 30 degrees. So angle DAB equals to angle CED equals to 30 degrees. And we also know that AD equals to ED equals to X. So we prove that triangle ADB can go into triangle DC according to side angle side rule. And from the fact that those two triangles can go into each other, we will derive that, we conclude that CD equals to DB. CD equals to DB, but we know that CD equals to 2 units. It is given us the question. From this equation we will derive that BD also equals to 2 units, BD equals to 2 units. Then we implemented the law of cosines in this triangle, triangle ADB, so I drew this triangle in a new page, and we implemented the law of cosines in this triangle, triangle ADB. So this is triangle ADB. You know that AD equals to X, DB equals to 2 units, and AB equals to 4 units. Angle DAB equals to 30 degrees, so according to the law of cosines, cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4. Cosine 30 degrees is equal to 3 over 2. X squared plus 4 squared is 16, minus 2 squared is minus 4, 16 minus 4 is 12. So in the numerator we have x squared plus 12. In the denominator we have 2 times 4 is 8, 8 times x is 8x. So in conclusion we have square root of 3 over 2 equals to x squared plus 12 over 8x. We multiplied this equation by 8x and we got that square root of 3 over 2 times 8x equals to x squared plus 12. Then we know that 8 over 2 is 4, so in this side of the equation we have 4 times square root of 3x equals to x squared plus 12. We divided, here we actually subtracted 4 times square root of 3x from this equation, and we got that x squared plus 12 minus 4 times square root of 3x equals to 0. Here we substituted 12 by 2 times square root of 3 squared because of the fact that 2 times square root of 3 squared equals to 12. And we got that x squared plus 2 times square root of 3 squared minus, we substituted 4 by 2 times 2, so we will have 2x times 2 times square root of 3 that equals to 0. This expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared that equals to 0. So we can substitute our expression by a minus b squared that equals to 0. In our specific expression, a equals to x and b equals to 2 times square root of 3. Therefore, a minus b squared will be equal to x minus 2 times square root of 3 squared that equals to 0. We took a root out of this expression and we got that x minus 2 times square root of 3 equals to 0 because of the fact that the square root of 0 is 0. We added 2 times square root of 3 to this equation and we got that x equals to 2 times square root of 3 units. So we can write here that x equals to 2 times square root of 3 units. Here also x equals to 2 times square root of 3 units. X equals to 2 times square root of 3 units. And here also x equals to 2 times square root of 3 units. Then we calculated the height of triangle ADB in order to calculate the area of it. From point D we draw perpendicular to AB. This angle is 90 degrees and this angle is 90 degrees. We define the touching point between the perpendicular from D to AB as point S. We defined SD as edge. And then in triangle ADS we know that sin 30 degrees equals to edge over x, that is actually square root of 3, that is actually sin 30 degrees equals to edge over x, that is actually 2 times square root of 3, or sinus in triangle ADS sinus 30 degrees equals to edge over 2 times square root of 3. Sinus 30 degrees is 1 over 2, so we got that 1 over 2 equals to edge over 2 times square root of 3. We multiplied this equation by 2 times square root of 3 and we got that edge equals to 2 times square root of 3 over 2. 2 over 2 is 1, so we got that edge equals to square root of 3 units. Edge equals to square root of 3 units. Now it is very easy to find out the area of triangle ADB because the area of triangle ADB will be equal to the base of the triangle that is AB times the height to the base that is edge over 2. AB is 4, edge is square root of 3 over 2, so the area of triangle ADB equals to 4 over 2 times square root of 3. 4 over 2 is 2, so we found out that the area of triangle ADB equals to 2 times square root of 3 square units. Then the only thing that is left to do is to find out the area of triangle BCD. Because of the fact that the area of triangle BCD plus the area of triangle ADB equals to the area of quadrilateral ABCD. So we found out the area of triangle BCD according to a special formula. First of all, we know that the semi-perimeter of any triangle equals to the perimeter over 2, and the perimeter of triangle BCD is 2 plus 2 plus 2 times square root of 3, 2 plus 2 plus 2 times square root of 3, and if we divide the perimeter by 2, we will get the semi-perimeter. So the semi-perimeter of triangle BCD equals to this expression. 2 plus 2 is 4, plus 2 times square root of 3 over 2. 4 over 2 is 2, and 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of quadrilateral of triangle DCB equals to 2 plus square root of 3 units. A equals to 2, B equals to 2, and C equals to 2 times square root of 3. And the area of triangle BCD equals to the square root of S minus A times S minus B times S minus C. S equals to 2 plus square root of 3 units. A equals to 2, B equals to 2, and C equals to 2 times square root of 3. So S is 2 plus square root of 3 units. B is S minus B is 2 plus square root of 3 units minus 2. That is to say it equals to square root of 3. S minus B is the same result because A equals to B, so it is also square root of 3. And S minus C is 2 plus square root of 3 minus 2 times square root of 3. That is to say it equals to 2 minus square root of 3. Square root of 3 times square root of 3 is 3. And 2 plus square root of 3 times 2 minus square root of 3 is, we did this calculation according to the algebraic identity that A plus B times A minus B equals to A squared minus B squared. Here A equals to 2, so A squared is 2 squared, 2 squared is 4. B equals to square root of 3, so square root of 3 squared is 3. So in conclusion we got here that A squared minus B squared is 4 minus 3. 4 minus 3 is 1. 1 times 3 is 3. So in conclusion we found out that the area of triangle BCD equals to square root of 3 square units, and the area of triangle ADB equals to 2 times square root of 3 units, and the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BCD. The area of triangle ADB is 2 times square root of 3 units, plus the area of triangle BCD is 1 times square root of 3 units. 2 times square root of 3 units plus 1 times square root of 3 units equals to 3 times square root of 3 units. So we found out that the area of quadrilateral ABCD in both methods equals to either 3 times square root of 3 units, so in terms of numbers it equals to 5.196 square units. Okay, thank you very much.